Hello dear student, welcome to my YouTube channel. In this video we will see structural isomerism and we will also see the concept of an isomer. Like the video and subscribe the channel for more updates. Now let us see further classification, that is isomerism, further concept, that is isomerism. Isomerism, it is a phenomenon of exhibiting two or more compounds with same molecular formula but different physical and chemical properties. Molecular formula is same but there are different and physical chemical properties. With example we will see one by one. And this isomerism, it is phenomena for an isomers. So isomers are the compounds which show different physical and chemical properties but have the same molecular formula. Again, the isomerism, it is classified into two broadly classes, that one is structural isomerism, or it is also said to be an constitutional isomerism, and second, that is stereoisomerism. Now the structural isomerism is that in which again the molecular formula is same but the structure it is different. Structure it will be different, and in case of an stereoisomerism, it is further classified into optical isomers and geometrical isomers. It means that there is only difference in 3D structures, or the difference, we can say the arrangement of an atom, it is different in the space, or we can say the 3D structures are different. Here 2D structures are different, means on the paper we can see the structures are different. Stereoisomerism also we can see the structures are different, but that has to be written in the proper way for to see the structures in 3D dimensions. And now we'll see the classes of an structural isomerism furtherly. So structural isomerism are the isomers in which the atoms are completely arranged in the different order with same molecular formulas. The structural isomerism is also called constitutional isomerism. Say for an example, we will take over an example of an, suppose say one of class example, that is butane. So butane, it has a molecular formula that is C4H10, but one of an isomer, that is isobutane. So say suppose I have written the isobutane. This isobutane, it is also having a molecular formula C4H10. Only the difference is that there is arrangement difference of a carbon skeleton, and the molecular formula is same. Definitely when the structure it differs, its properties will be also different, right? So that is why it is said that physical and chemical properties are different. So physical properties like melting point, boiling point, refractive index, so that properties are different, and also like chemical properties like reactivity, it will be different because the structure it is different. So that is why it is said to be that physical properties as well as in chemical properties, they are different for an structural isomers, but molecular formula is same. Now let us see the classes of an structural isomerism. There are totally 5 classes: chain isomerism, after that positional isomerism, after that functional isomerism, after that metamerism, after that tautomerism. So these are the 5 classes of an structural isomerism. One by one we will see the class. First class, that is chain isomerism. Chain isomers means what? There is difference in a chain. Difference in a chain of an carbon to carbon. Say for an example, just we have taken over an example over here of an butane, N-butane and isobutane. So in case of an N-butane and isobutane, see again I will draw the structure of an N-butane and isobutane. Why it is said to be an chain isomerism? So there is no involvement of any other different substituent atom. Different substituent atom means there is no different element, there is no substitution of halogen, or there is no any functional group. In other classes we can see such kind of an differentiation, like suppose say N-butane and isobutane. So these are the two examples of an chain isomerism. Only chain it is different. So this is the structure of N-butane, and second structure it is of an isobutane. So isobutane and N-butane, they are having a different chain. It is straight chain, and this one is a branch, right? Straight chain and branch. After that, positional isomerism. Positional isomerism arises when there is difference in position occupied by substituent atom or group of atom. Here, there might be another substitution than a carbon. In case of a chain isomerism, we have seen only there is a carbon, but here there can be a difference of a substituent, different element. So let us take an example like C3H7Br, right? So there can be change in bromine substitution. So bromine substitution, say suppose example, for an example, say this CH3, CH2 and again CH2. So number of carbons are 3 and number of hydrogens they are now 7, and bromine it is attached at number 1 position. So this structure it becomes 1 bromopropane, and second structure, say suppose molecular formula is same but difference in substituent atom, position of an substituent atom. Now the name of this structure it is what? It is 2-bromopropane. Structures, molecular formula is similar but structures are different. Structures are different in what sense? In sense of position of this functional group, or we can position of an substituent atom. Position of an substituent atom it is different. Now functional group isomerism. Functional group isomerism it indicates that functional group isomerism occurs when there is presence of an odd form of functional group with same chemical formula. Say suppose molecular formula it is C3H6O. It can be either propanol, that is aldehyde, or propanone. It can be a ketone also. Say for an example like I will draw a structure here of an aldehyde, that is propanol, CHO, and ketone, that is propanone. Name it is indicating that functional group it changes, right? Functional group. So it can be very easily been remembered that functional group it changes. If we see the molecular formula for this structure, first structure, it is H6O, right? And similar for this C3H6O. But functional group it is different. Molecular formula is same, but functional group it is different. Now metamerism, that is fourth class from structural isomerism. The same molecular formula represents two or more compounds. Molecular formula it will be always same in case of an structural isomers in all the classes. Now in case of an metamerism, what we it differs in nature of an alkyl groups attached to a same functional group. Say for an example like diethyl ether, propyl methyl ether, or isopropyl methyl ether are the metamers of each other. Functional group it is same. In case of metamerism, functional group it is same. Only there is difference in alkyl attachment. Say suppose say diethyl ether. So this is an structure of an diethyl ether. And if we see the structure of an propyl methyl propyl ether, so this is the structure of an methyl propyl ether. In case of an metamerism, it is having oxygen, it means it is having an ether, right? And the chain on either side of an functional group, it is different. So here it is having C2H5, or we can say ethyl, and it is di, means on both the sides it is having ethyl, so that is why diethyl. And in case of an methyl propyl ether, see this methyl group, it is on the either side of an functional group, that is oxygen ether, and propyl, here it is propyl, and in between functional group, that is ether. But the molecular formula, it is same. If we count the carbon, number of carbon, they are 4, and number of hydrogen, they are 10, and oxygen. So similar over here also, that is carbon are 4 and hydrogen, they are 10 and 1 oxygen. And also one more example, that is isopropyl methyl ether. So that is also a metamer of this compound. I will draw the structure of that isopropyl methyl ether. A methyl group, and after that so this, it is an iso, right? Isopropyl group, so that is why isopropyl methyl ether. So all these three compounds, they are metamers of each other. Now the last class, that is Tautomerism. Tautomerism is a phenomenon where a single chemical compound tends to exhibit two or more interconvertible structures, and they exist in dynamic equilibrium. Say suppose a keto form and enol form. You can see that structures are similar. So not structures are similar. The number of carbons and number of hydrogens are similar. Here there are 3 carbons and 1 oxygen, and while hydrogen there are 6. So similar in the case, oxygen is 1, and there are 6 hydrogen and 3 carbons. But the only difference is that this form, it is keto form. Why keto form? Because here it is having a ketone functional group. But after interchanging, it forms an enol form. Enol means alcohol. The carbon, it is having an alcoholic group, that is why an enol. But the more stable form, it is an keto form, which exhibit in 99.9% at the room temperature, and enol form, it is very less. And these are interconvertible. So very important that these are interconvertible structures. Not it happens that keto form directly goes into an enol form permanently. Again it will come back, but at the room temperature, more stable it is an keto form, and enol form, it is less stable. So that is why they are said to be tend into a dynamic equilibrium. Dynamic means they are reversible. This reaction, it is reversible, or the structures are reversible, so that is why it tends to be a dynamic equilibrium. Only the change is that it is having a keto functional group, and here the change is that it is having an enol functional group or alcoholic functional group. And here you can see that electrons, they are being donated towards an hydrogen, and now hydrogen get attached with the oxygen. Always remember that this arrow, it is for transfer of electron. It is not for replacing the hydrogen over here. Many students write, whenever they are transferring hydrogen over here, they will write the arrow in an opposite direction. But this arrow, it is a fishword arrow, which is only for transfer of electron, which is showing that electrons are being transferred towards an hydrogen, and hydrogen, it is liberating electron towards the carbon and carbon, which forms a double bond. And here there is one more thing, that this pi bond, it breaks, and it transfers the electron towards an oxygen, and that is why it bears a negative charge, which it means that it is having an extra electrons, and these electrons, now they will abstract the hydrogen from here, and it forms a new bond. While this hydrogen, when it is leaving, it liberates the electron towards carbon-carbon double bond, and it forms a new pi bond. means all the bonds, one pi bond formation is there, and one sigma bond formation is there, and similar way one pi bond will break and one sigma bond will break. Thank you for watching the video. If you are having any doubts, you can comment me in the comment box section. I will surely answer it.